Hi, let me introduce you to the application TouchPlot. This application is a very powerful grapher, as you can guess from its main menu, and I will show here some of its more basic features. First, let's enter the submenu of the f function. As you can see, the menu is now quite short, but it will get populated with other options as soon as a valid expression for f has been defined. For that to happen, we could load a function from a library of functions, or instead introduce a new formula, which we will do now. So this is the formula editor. It has been completely redesigned for version 4 of TouchPlot, although the changes are not obvious at first. There you can see that manual parentheses appear on the keyboard, whereas parenthesis introduction were automatic on previous versions of TouchPlot. The vars key lets you introduce a variable amongst A, B, C or D, of which you can define the value in the constant submenu, or putting a slider on the graph to adjust their values live. As you can see, the numeric keypad is not complete, but with the key num you can obtain a complete numeric keypad to introduce any numeric constant. The digits on the keyboard are there as shortcuts. Parentheses always come by pairs, so only one touch is needed to enter a couple of them, but of course it means that a key is needed to go outside some parentheses. As you can see, the key devoted to that action is the right arrow, which, along with the left arrow, allows you to navigate through the formula. The editor makes use of implicit multiplication when it makes sense, so here I have no need to enter the multiplication sign. So here it is, the formula is complete, so we can validate it. You can now see the full menu, with new options such as Save F, which will put a copy of the F formula in the library, on top of the list as you can see there. You can of course organize the library as you wish, reorder, delete etc. You can also compute a symbolic derivative for f function, as well as draw, or not, the said derivative. The same choice applies to f graph, and you can choose its color. The sequence option lets you study iterative sequences. There will be a separate tutorial about that. You can calculate values, defining the first value, a step, and the number of values to be displayed. And you can calculate, numerically, definite integrals, but as we will see, you can do this graphically as well. So let's draw the f curve. The graphical display makes extensive use of multiple touches. Note that if you wish to display a full screen graph, you can get rid of the top and bottom bars by pressing the cross button on the top right. To get back the bars, just double tap anywhere on the graph. The role of gestures depends on the current mode, such as it appears on the bottom of the screen. With the first mode, you can translate the window, or zoom in and out, independently with both axes. You can also look for zeros by choosing the corresponding mode and touching near zero. The same holds for minimum and maximum inspection. You choose the mode, and you touch the screen near the position of an extremum. Then you can display values calculated along the curve with the inspection mode. And finally, with the last mode, you can calculate and show a graphical interpretation of definite integrals. Maybe it would be more desirable to truncate the abscissa, instead of leaving, such as it is now, full precision abscissa. It is possible to do just that by visiting the constants menu from the main menu. Let's do it and go to that menu. A truncation will be applied as soon as the minimum step has a value different from 0. And there is the result.